homework time. Here we go. The final homework lesson in Module 1. This is where you put it all together and you really make it work for you because you write the word problems today. Let's jot our names down to start off with. I'll write my name. You write yours. How's that for a deal? If you were me, you'd write my name and I'd write yours. But it's not the way it is. And then let's jot down today's date. Anything worth doing is worth doing well. Let's do this the best we can. So here are simple instructions. Using the diagrams below, here's our diagram, create your own word problem. Solve for the value of the variable. And we've been using variables all along here. We can see right here, A is what we'll be solving for here, dogwood. All right, so let's see what they give. They kind of give us a fill in the blanks here. At the local botanical gardens, there are blank redwoods and blank cypress trees. All right, let's just pause for a moment. Those are given to us. We can see that right here. So we can just write in these values. We see how many redwood trees there are. 6,294 redwood trees. And we see cypress is given to us as well. 3,849. All right, let's fish on. There are a total of blank redwood, cypress, and dogwood trees. And we see that that's this bracket, the total. You see how the bracket encompasses all three trees? So that would be this 12,115 is the total for all three of them. Now, when we're told to solve for the value of the variable, that A identifies the number of dogwood trees. That's the only unknown. We know redwood, we know cypress, we know the grand total for all three. We don't know dogwood, so let's find out. So that's going to be our question. How many dogwood trees are there? They gave me way more space than I needed to write. So I'm going to put my own question mark here, and there's one at the bottom. Okay, so we can see that if we combine redwood and cypress first, we can then subtract that from the grand total to get dogwood. So here I'll even draw my own extra little bracket. I want to figure out redwood and cypress together, which I can then subtract. Okay, so let's do just that. I'm going to have to work over in the margins here because I'm sort of running out of room, if you don't mind. All right, so it's 6,294 redwoods and 3,849 cypress trees. If I put those together, okay, 4 and 9 make 13. We group that 1. See a pattern here, 1 and 9 make 10. 4 more is 14. Good. 8 and 2 make 10, and 1 more then is 11. Group the 1. And here's another make 10 fact. I can look at it as 7 and 3 make 10. Excellent. Drop that comma. So I'm going to write that over here. That's redwood and cypress, 10,143. If I subtract that from the grand total, I'll get dogwood. And you can do a pretty quick estimate. You see they are 2,000 apart, these two numbers, and they're both in the hundreds. So it's going to be around 2,000 dogwoods, which makes sense. Even they drew it, so that would be the smallest one. So if I take that 12,115 and subtract the other trees, the 10,143, that will give me the value of the variable A for dogwoods. So 5 minus 3 is 2. Now 1 minus 4 I can't do without regrouping, so I'm going to go over here, take that 100, bring it over here as 10 tens with the 110 already there. Is now 11 minus 4. Do 7, good. And again, I can't take 1 from 0, so decompose this 1,000, leave one of them there. Bring over the 1,000 I need as 10 hundreds. There were 0 hundreds there, so I have 10 hundreds minus 100 leaves, 9 hundreds. I realize I'm writing it more and more of a slant here. 1 minus 0 is 1. And very good. Wasn't our estimate around 2,000? And I'm going to use this space here. I'm going to kill their comma and write my solution for the variable over here. And notice this does not say I need to write a statement. I'm just going to simply say A, which is what they designated for the variable, equals 1,972. That's how many dogwood trees there are. Excellent. You see how these work? It's pretty cool. I like these. All right, let's go on to number 2. Well, was that the sound of your jaw hitting the floor? Boy, they completely took the training wheels off here as we get to number 2. So let's just look at what we have. There are 65,302 somethings. There are 37,436 fewer whatevers. How many? And we have to see what we're solving for. Okay. So here's the 65,302 somethings. That's this first tape. And then we know that the whatevers is 37,436 less. And you see the variable we're solving for, which is t, I'm going to guess for total, is the two of them combined. So together, or total, okay? So we need it together. Now, you could write whatever you want to be 65,000 somethings and 37,000 whatevers, okay? I don't know. Hamburgers, 65,302 hamburgers. And where are they? They are in my trunk. Why not? There are 37,436 fewer, well, what goes with hamburgers, but hot dogs. In my back seat. And as my car is not refrigerated, even with the AC cranked, this meat is all going to be going bad pretty soon, especially in the weather we've had. So how many, what? Tasty meat products are there in all? Now please, for the love of hamburgers and hot dogs and corn, don't copy what I wrote. Come up with your own thing instead of hamburgers and hot dogs. It could be anything. If you're wondering what to do, maybe you can just like look around the room you're in and be like, oh, computers and iPads, or dogs and cats, or pencils and erasers. It doesn't matter. You just need 2 things, and then you're asking how many together, okay? I got dibs on hamburgers and hot dogs. All right. So we know we have to figure out hot dogs here, okay? So I'm going to write ham, short for hamburgers. I'm going to write hot, short for hot dogs. Ham hot. All right, so to figure out the hot dogs first, if I take how many hamburgers there are, remember we do actually have to do the calculations to solve for the variable. If I take how many hamburgers there are, and then subtract the difference between hamburgers and hot dogs, that will give me the number of hot dogs, which I need in order to solve for my variable t. Okay, so it looks like they're getting us back with mega regrouping here. I cannot take 6 from 2, so I go to tens place. There's nothing there, so I keep going. There's a 0 there, I should say. And I go to the hundreds place. I leave 2 of those hundreds as is. Bring the 10 tens, that 100, over. That doesn't help me in the ones place, so I'm going to take one of those tens, leaving 9, and bust it out as 10 ones combined with the 2 ones already present in the ones place. And we did all this already, so I'm kind of cruising through it. So 12 minus 6 now I'm doing. Oh, that I can do. That's 6. 9 minus 3 I can also do. Well, likewise, that's 6. I do see 2 minus 4. I need to regroup again. So go to thousands place, leave 4 of those thousands as they are. Bring over one of the thousands as 10 hundreds, with the 2 hundreds already there. So now 12 hundreds minus 4 hundreds rather, is 8 hundreds. In thousands place, I cannot subtract 7 from 4, so I need to go to 10 thousands. Leave 5 of them there, and then one of those 10 thousands I will make 10 thousands, with the 4 thousands remaining in the thousands place. So 14 minus 7 is 7. And now 5 minus 3 I can easily do is to drop that comma. Now that's the number of hot dogs, right? Because the hot dogs are fewer than the hamburgers. 27,866. Okay, now I want a total for hamburgers and hot dogs all together. So if I look at the number of hamburgers plus the number of hot dogs, that will give me a total for tasty meat products going bad in my car. Great. And let me put them together now. So really, that's a 6, sorry. Okay, 2 and 6 make 8. 0 and 3 together, 3. 3 plus 4 is 7. 5 and 7. You know that one? 5 and 7? Got it? 12. Good. Place the 2. Regroup that 1. Drop the comma while we're here. 1 and 6 are 7, and 3 more make 10. All right. So now I have a value for t. T equals tasty meat products. That's what T stands for. 102,738 tasty meat products there in all. Well, guess what? The beauty of this, though, is that we're halfway through. Let's go on to number 3. All right, don't freak out. I know they're giving you just like, what? This picture and nothing? Okay, we can do this. Don't worry. Use the following tape diagram to create a word problem, and we will solve for the value of the variable. So important thing here, notice first, is what are we trying to solve for? Okay, well, we have 3 things, whatever they are, and we're given the total of the 3 things, and we want to solve for the first one. Already, you're probably starting to get your head around it there. Okay, so what are 3 things? And again, just cast about the room. Come up with your own thing, would you please? Just any 3 things. What do you have? Okay, so let's do, I'm going to do, you can do something different, please. I'm going to do pencils, pens, and crayons. All right, it's a nice school-related little thing. Okay, so you see what I'm trying to solve for. A is pencils. You can make up whatever you want. And then pens, we can see, there's fewer pens, but we're not comparing pens to pencils because we don't know what pencils is. pens is being compared to crayons. And crayons we actually are given a value for. So when I go to write my word problem, I'd like to start with maybe this grand total and the number of crayons. Okay. So let's make up who would have over 200,000 pencils, pens, and crayons. I don't know, maybe like a truck delivering to Staples crashed on the highway or tipped over or something. Nobody was hurt, don't worry. But let's say we have an art teacher, and her name is Ms. Sneggle Bossum. Miss Snegglebossum, the art teacher. And what does she have? Let's start with that grand total we're given. Has 215,561 drawing implements, tools. All right, drawing tools. And now what are we given right off totally? We know that the number of crayons, okay? And I'm telling you, don't copy mine. It's trademark. My lawyers will be after you. Okay, that's not true, but make up your own thing, okay? Have a little fun with it. Don't go crazy, though. She has 42,086 crayons. You could do fruit or something, right? It could be 3 types of fruit. Go through rooms of your house to come up with ideas. Like you can either physically walk through rooms of your house or just mentally think, oh, okay, I could do cookies, cupcakes, and this, I don't know, so 3 types of candy, or maybe you go into the bathroom and you have soap and shampoo and conditioner, or body wash, shampoo, conditioner. There's 3 things, and they're all shower products. You just need 3 things that go together. So she has 42,086 crayons. Now her pens, you see, are more than the crayons, and it tells us how much more, this 36,538 number. Okay, so I'm just going to keep it simple here, just keep the wording simple, not get too fancy. She has 36,538 more pens than crayons. Okay, and then the remainder of this 215,000 is what? Pencils. So that's exactly what we'll say. The remainder, the rest, you could just say the rest, of her drawing tools are pencils. And now we do need something of a question going on here, right? How many pencils does she have? That's the variable we're trying to solve for. So how many pencils hath she? I'll just say, does she have? Okay, question mark. So now to do the math, we can see, we know crayons, right? And we know pens are that much more than 36,000. So if we put those together, we'll get the number of pens. So let's start by doing that. We'll take crayons, 42,086, and say, okay, well, there are 36,538 more pens than crayons, and that will give me the total number of pens. So let's do that. 6 and 8 make 14. Regroup that 1. 1 and 8 make 9, and 3 more is 12. Good. Regroup that 1. 1 and 0 and 5. 6. 2 and 6. 8. Drop that comma while we're here. 4 and 3 make 7. Okay, so we have, and I'm going to write it inside pens here so I don't forget what that number represents. It's 78,624 pens. Okay, remember what we're trying to solve for is the number of pencils, this letter A up there. So now in order to subtract pens and crayons from the grand total of drawing tools, we need to put pens and crayons together. So if I take that 78,000 pens that I just solved for, 78,624 pens, and add to it the number of crayons, 42,086, that will give me pens and crayons together. Alright, so 4 and 6 make 10. And you see the pattern here. 8 and 2 are 10. One more is 11. Regroup that 1. 1, 6, and 0. Deed is 7. 8 and 2 again make 10. Regroup the 1. Drop that comma. 1 and 7 make 8. 4 more is 12. Very good. Okay, so she's got a whole lot of pencils, which makes sense, right? They're the cheapest of these, I believe. So 120,710 is pens and crayons together. If you want to, if you can fit it in there, I'm going to say, hey, I just want to make a note for myself what that number represents. That's pens and crayons together, 120,710. See, so to find A, the variable, which we've designated as pencils in this example, we take the grand total of writing tools, drawing tools, and subtract pens and crayons. That will leave us with pencils. So let's do that. 215,561 drawing tools. We subtract pens and crayons, which we just solved for, 120,710. That will give us pencils. So let's do it. 1 minus 0 leaves 1. 6 minus 1, yep, 5. Now we can't take 7 from 5, so we're going to do a little decomposition action here. Go over to thousands, leave 4 of those thousands, bring 1,000 over as 10 hundreds. With the 500s already there is 1500s, minus 700s. 15 minus 7, that is 8. And we have 4 minus 0 is 4. Drop that comma. We can, you can do this 2 ways. You can look at 21 minus 12 and get it right. Or we can do the regrouping, which we'll do. We'll go over here because we can't take 2 from 1. Leave 100,000. Bring the other 100,000 over as 10 10,000s with the 1 10,000 already present in the 10,000s place. And we can do 11 minus 2 leaves 9. See, and 21 minus 12 is also 9. 1 minus 1 is 0. We don't have to write that there. So she has, this is our answer for A. This is our final answer, the variable. She has 94,851 pencils. So that is the value of the variable. Okay, woo, they're complicated and they're difficult in a way, but they're very rewarding puzzles to solve, aren't they? Well, we got just one more pleasurable puzzle to unfold. Let's move on to number 4. Well, looks like they're giving us a bit of a doozy here. We're just given this equation. We have to do the whole tape diagram and the whole word problem and solve the word problem too. Man, I think the Eureka Math people went on vacation and said, just let the kids do the work for us. No, I'm kidding you. All right, so let's look at what we have. We're given 27,894 plus the variable a, that's some unknown number, plus 6,892 will equal 40,392. Okay, so we see we have 3 components. We have a total, and we're just missing one of the components. This one, in a sense, although we have a little bit more to do in a way, actually is not as complicated as that last one we did. So, cast about, what can we do? Well, I was saying we could do fruit, okay? So let's do fruit on this one. Let's have 27,000 apples. Okay. And I'm going to do with a bracket up here, 27,894 apples. And then we have this A amount, which we don't really know. So let's leave that for a moment. We'll come back to it. Then we have 6,892. Well, I don't know. How about oranges? Sorry to be not quite as creative in this one. And again, I'm doing fruit. You're doing your thing, okay? Get your own thing. And this one I'm going to... The tape is proportionally too large, but, you know, it's okay. 6,892 oranges. I'm going to write it inside because I have room there. And then this A, well, you know what? Just so I know how to draw A, let's do a quick estimate. Let's round to the nearest thousand on these. This will be 28,000. Okay. This will be 7,000. Together, 28 and 7 is 35. And our total is 40. So 40 minus 35 is 5. So A is probably going to be smaller. So I can draw that tape smaller. And how about we do, I don't know. Oh, let's do kiwi. They're fuzzy. Yes, they are. Okay, so kiwi is going to be our variable A. And now this 40,392, well, that's everything all together. That's all the fruit in the fruit truck. Okay, 40,392 is everything all together. So we know apples, we know oranges, we're trying to find kiwi, we know the grand total. So you see how I say that this one is even a little bit easier. Let's do the math first. Maybe that'll help us to write the question. We know if we put apples and oranges together, as we did in our estimate, and then subtract that from the grand total, that will give us the missing number, the kiwi, okay? I'll make that look more like a comma, less like a decimal. Okay, so I like to put the larger number on top, so 27,894 apples and 6,892 oranges. Okay. All right, so let's add these up. 4 and 2 make 6. 9 and 9, you know your doubles, 18. We group that 1. 8 and 8 are 16, you know, and 1 more makes 17. Regroup that one. And see the pattern here? Because if you know your doubles, you'll say, 1 and 6 are 7. 7 and 7 are 14. regroup that one, drop that comma while we're here. 1 and 2 make 3. Okay, so apples and oranges together is 34,786. And if we subtract that from the grand total of frutas, that will give us kiwi. So let's do that. The total number of fruit is 40,392. And we'll subtract from that apples and oranges, 34,786. And that will give us the number of kiwi. All right, so we do 2 minus 6. Oh, we got regrouping right at the beginning here. Okay, so we'll leave 8 of those 9 tens alone. Bring 1 over with the 2 ones already there. It's 12 ones minus 6 ones is 6. 8 minus 8, 0. We need to decompose here a little bit to subtract in the hundreds place, because 7 is greater than 3. So we go across this 0 over to the 10,000s place. We'll leave 3 of those 10,000s intact. And now this is where you can start saying, okay, I know I have to do this, so I'm going to compact, not so much skip a step, just compact it. I know I have to do 10 and then cross it out and write 9. I'm just going to save myself the trouble and bring one of those thousands over to the hundreds place as 10 hundreds with the 300s already there. Now, watch the subtraction happen. 13 minus 7, yeah, leaves 6. And in the thousands place, 9 minus 4 is, got it, 5. And wasn't that our estimate, around 5,000, which was a very rough estimate. 3 minus 3, of course, is 0, which we don't write out there. So I can actually write, even though I haven't written the question yet, I wanted to do the math first to help get my head around what I'm doing. So I'm going to have, this will be the answer to the question I haven't even asked yet, which is the variable a. How many kiwi are there? There are 5,606 kiwi. I don't know if kiwis is more correct. Usually where that ends with that I. All right, we'll just leave it like that. There are 5,606 kiwi. So our question is going to be, let's have a produce company, and we'll call them Brothers Produce, because we have an in-laws produce company here in our town of Savannah, Georgia. So that's where I got Brothers from. Brother Produce loaded a truck, or loaded a fruit truck. How's that? So again, you are not stealing my idea of using fruit. You come up with your own thing. I mean, heck, you could do vegetables. Like, walk your mind through the grocery store. You could do 3 types of crackers or cookies or potato chips or ice cream or cheese or yogurt or I don't know, fish or whatever. You don't have to do fruit. Please don't. Loaded a fruit truck. With, let's give our grand total, 40,392 pieces of fruit. Good. Okay, now they loaded, let's start with the apples, huh? Is that because we're given that? They loaded 27,894 apples. 6,800, ooh, that's a sloppy 8, sorry, 892 oranges, and now when we get to kiwi, that's just going to be the rest, right? And the rest were kiwi. Okay, and the question we've already answered is how many kiwi did they load? Wow, and so look at that. Look, we did the complete tape diagram here. We did the solving, we wrote a statement, and then we wrote the word problem. Well, great work. Whoo! Yeah, that makes your brain hurt a little bit, all that figuring that stuff out. But great job. You are done not only with homework time for tonight, you're done with Module 1. You'll be going on to Module 2 next. Excellent work. Homework time is done.